Alright, so let's talk about virtual environments. Basically, the idea is that you can have packages installed for a project that don't impact other projects. So, you could have a different version on one project and an entirely different version for the other project. It's great for just simplifying your life. It really is. At the same time, it can be confusing because you might be expecting to have discord.py installed, but you don't. So, because it's installed on a different project. Let's real quick jump into how exactly Python organizes all that. So, let me bring up my other window. All right. Let me know if you can read all that. Like it might be small. I'm trying to see if everything is the proper size. Alright, so we see how we have a VM directory here in this project. And if we look in that directory, we have like a bin folder, we have a lib folder, we have a few different things in there. And let's just keep drilling down, and we're gonna look at the bin folder. Now, notice we have like a link to Python, we have a link to Python 3, Python 3.10, and then there's pip, and we have wheel, a whole bunch of different things in here. And like we have this activate. And what that's going to do is it's actually going to tell your system to use this Python link. And you see it's pointing to my system install of Python 3, Python 3.10. All right? So whenever we want to use that, it's going to be as, I think this should work. Let's see if this works. Why is it not working? Just got this computer, so everything is not working. Oh, right. Source. So let's activate that. There we go. Now we have, it's using the virtual environment. You see how it says right over here, VMV. Alright. Just making sure everything's good in chat. Looks like it is. Alright. Okay. So we've got this virtual environment set up. So now we can do, let's just do like, oh my gosh. How do I, trying to think of how I can show the packages are installed. And I can't remember the command off the top of my head. So let's just be a good software dev and Google that. Pip list packages. Alright, there we go. Pip list. And we don't really have a whole lot installed. So then I could do pip install. Let's do discord.py real quick. Just real quick installing that. Now this is getting installed into my virtual environment. So it's not going to be available on the global installation. And we can, so like if I do pip list, now we see we have a whole bunch of packages. And then if I do deactivate, if we could spell, and then if I do pip list, doesn't even have pip there. Pip 3 list. There we go. Notice there's nothing there. So then if we redo that activate, it will bring back, there we go, all of our stuff. So like you see how like my global installation doesn't have all the stuff we just installed for the Zech.talks code project. And that can be really useful. Especially if like you're installing stuff from other projects, like things on GitHub. You don't have to install everything that those you don't have to have that stuff already installed. You can just install it inside the virtual environment for the project you got from GitHub, whatever it might be. I hope that makes sense. If you have any questions, pop them in chat. All right. So now, like, you've seen how, like, I've activated it and how I've deactivated it. Like, if we jump over to PyCharm, this is something that trips people up on PyCharm. Because PyCharm created this virtual environment for me. And I can see that by jumping into the preferences. Don't know if I can make that larger. I don't think I can. But I can jump down here. And I can go to Project. And I can go to the Python interpreter. And they have let me select. And like you'll see, if I come over here and I go to Show All, this is actually using the VM. Like you can see it right here. So I could add another one and switch what that one is using. I can use an existing environment. I can create a new environment. And that really trips up a lot of people with PyCharm here. But it lists out everything that's in that virtual environment right here. So you can see everything you've got. And then we can literally do import Discord and it'll show up right there because it sees that we have it installed. Like we can see all the sub packages and everything because we have it installed in the virtual environment that PyCharm is using. Yeah, I'm not sure what next to talk about. But yeah, it's useful, it's handy, it helps isolating your projects from other projects. Is there anything else anybody else was interested in knowing about virtual environments? I know there were some questions about virtual environments. They're actually pretty straightforward, so there's not a whole lot to talk about. Any questions? I see Void says, no, sir. I guess I answered all his questions. Who asked that question? We can jump over and we can find out. Let's see. That was Bobby. Bobby asked about... Is Bobby in here? Bobby's in here. Alright. So I guess if he has any other questions, he would already have asked them. Alright. Let's see, just looking through chat here real quick. We've been going for 10 minutes. Maybe. It's been only 10 minutes, so maybe we could jump in here and we can look and see if there's maybe something else. Got my tall monitor over here, my ultra wide and vertically, so I'm kind of looking up at the sky here. I use, Alexander's was asking which projects I use virtual environments for. I literally use virtual environments for every project I do. Doesn't matter if it's a one-off or whatever. I just don't want to install packages. The only packages I install globally are Black, Poetry, stuff that I use to manage my projects. That's the only thing installed globally. Everything else gets installed in a virtual environment just so I can manage the versions. And that's another thing with versions that's really useful is you can pin the version that you're using. So you can prevent a version from getting updated. So if you ever look at a requirements.txt file, you might see that it has the equals for the version. And that makes sure that every time someone installs that project, it always has the exact same version of each of the dependencies for that project. So if someone ever added a breaking change to their package, you would be pinned to the version that doesn't have that breaking change for you. So your code will continue working going forward, even though that other packages that you depend on might be getting updates. Those updates aren't going to break your package. Alright, this spammer. Were you not paying attention earlier on when I explained what a virtual environment is? I'll just real quick to recap. A virtual environment is just a project scoped installation of Python, essentially. It's a little more complicated than that, but basically it lets you, whenever you pip install something, it only installs for that virtual environment. So anything you have installed globally won't be available in the virtual environment. Well, you could set it up so that they are. And anything you install in the virtual environment will not be available outside that virtual environment. So it gives you some isolation. Whichever version you used, I mean, it whatever you link to, like where I showed it links, we can show that again. Like, you see this link right here. That's what is going to be used. Whenever you type Python, it's going to run that file right there. So whatever that link points at is going to be the Python version that gets used. So I will generally use like PyEnv on my Mac to install multiple versions of Python. And then I will use the virtual environment with the version I need. So I can literally pin to like Python 3.6 or Python 3.9, or most of them will be on like the latest version. It's super convenient. Like, I know, like for our Discord bot, it's still running 3.8 on one version of the bot, and the other half is actually running on 3.10. So they're in the same GitHub repository on different branches with different VMs. So I can literally have it that like granular. Can you make a compiler with Python? Yes, it won't be the world's fastest compiler. Depends. It would get really tricky building like a proper compiler. Building an interpreter would be a lot simpler. I actually built a brainfuck compiler using Python, or interpreter with Python, which you can use with the bot. And you officially got me to say the F word on a stream, on my first stream. Good job, I guess. Let's see. Any other questions? And like, I'm looking at the chat here, so I'm not looking at the camera a whole lot. Gotta get used to that. Yeah, that's true. It doesn't really count because it is the name of the language. It's conveniently named to screw with live streams, I think. All right. The difference between C++, C, and Python, well, C++ and C are systems languages. They compile right down to machine code, whereas Python is an interpreted language. Technically, it does have its own bytecode that it compiles to, but that gets run through a C-based program that runs through a loop going through each opcode, running a bit of C code that handles each thing. So like a for loop will get turned into an opcode, and then like those opcodes will have instructions. You can actually use the disk command on the bot to discompile Python code, and you can actually see all the instructions get generated. Yeah, Python is a very general language. You can use it for just about everything. I wouldn't use it to build an operating system, but like, you can build websites, you can build Discord bots, you can build anything you can imagine. It's a good prototyping language for like just getting ideas fleshed out, and like once you get up to scale, you might want to like think about moving to something like Rust or Go. because they're a little more performant. They can get a lot more out. Like, looking at the stats, Python can generally handle like upwards of 100,000 connections on a web server, and Go can like get an order of magnitude upwards of 1 million more. So it's a good bit more. What's the difference between a compiler and an interpreter? Well, a compiler takes the code you've written and it converts it into like in the assembler instructions, and then those assembler instructions can be converted to machine code on a simple level. Like, that's on a simple level what's happening. An interpreter is going to go through the code and it's going to read that code and it's going to run other code that understands what that code is. So if you have like a for loop in an interpreted language, like with Python, there's a function in the Python C code that actually does a for loop. It understands how a Python for loop works, and it runs that for loop. Whereas with a compiler, like with C, it's going to generate the assembler that's literally going to go through instruction by instruction, load each value into a register on the compiler, and it's going to jump back when it hits the end of that loop to the prior instructions. So it's literally telling the CPU, run this instruction, run that instruction, rather than being like a function in some C code like you have with an interpreter. Do I understand how binary and the CPU work? On a fairly high level. Binary is a number system. I can do math in binary. Like, how CPUs work, that's a whole nother level. That's a whole academic field. Like, there are people with PhDs building CPUs. So do I understand how a CPU works? On the basic level, I can't go out and build a CPU. What issues have I faced with virtual environments? Not really any. Like, the biggest issue is for beginners just understanding how they work, and understanding just like how to set them up, how to activate them, how to deactivate them, when they should be using a virtual environment or when they're not using a virtual environment. Like I said, that's a big catch point in PyCharm for a lot of people, because they create a project and PyCharm creates a virtual environment for them, and then they jump over to the terminal and they don't know they need to activate that virtual environment. So they have discord.py installed and it's not available in PyCharm, or it's installed in PyCharm and not available in their terminal, and it leads to confusion. So that's where I've had the most issue, is getting people who don't understand how virtual environments work to use a virtual environment. And are they making execution slower? No, they're not. It's just loading Python with the packages that are installed. The packages are actually, let's see if we can find it. LL. They are going to be in lib. So if we do LL VM lib, you can see we have 310 site packages. So like, if you actually navigate over to Python on your hard drive where it's installed, you'll see inside the Python's the folder it creates when it was installed, there's a site packages folder. And so like, when you look inside the site packages folder in the VM, like, you'll see here's everything we installed. All the packages, all the files for all the packages are here. So what's happening when you activate the VM and then you run Python inside that VM, instead of using the site packages folder that was installed with Python, that's in its installation folder, it instead runs with the site packages folder inside your VM folder. So it's not slowing it down in any way. It's literally just changing what folders, where it's looking for the packages. That's all it's doing. So it's not making execution any slower. It's right at the runtime. As soon as you run Python, it's changing how it runs. So, on the subject of projects, Moses is asking if I could walk you guys through the file structure for projects, for like Python projects, because he's seen Java projects and in web development and such. A great thing to look at, like it's really going to depend for Python. There's a lot of different ways people do it. There's like I know we have like PEP 8 for how we organize like our code and how we make our code look. There's not really like a PEP for how to organize your project. So a lot of it's just convention. The one like big exception is if you're trying to create a package where you're going to use like dundernit.py or dundrmain.py. But on a more basic level, the way I organize my projects is I'll have like the project folder. Let's see if I can. There we go. I'll have like a project folder. And I'll put inside that project folder the actual package folder. So like the project folder itself isn't where my code is going to exist. That's not where I'm not going to run that folder. I'm going to be inside that folder, and I'm going to have another folder that I'm going to be running. So like here with this project folder, I would make dir package, and then inside a package I would do a dundernit. What happened here? Something. Make dir. I'm thinking something wrong here. Yeah. Brain ain't working great. There we go. Here we go. There. Don't know what happened. So then we're gonna do init.py, and that's gotta go inside the package, right like that. And then I might do under main, so we can run our package, right like that. And then we can literally do. Let's just add something real quick to package. Print hello, and then we can literally do python-m package, and it'll print hello. So basically, that's how I'm going to organize it. Anything, so like I can put all my config files inside the root directory, like our zech.talks code folder would be where I would put all my like config files. I'm going to put my requirements.txt, my readme.md. Like, all that's going to go inside the root folder. And then all of my code, this is just how I organize it, is going to go inside my package folder. And, like, I'll name, like, the package folder. Like, I have my Bevy package on my hard drive and in my GitHub. It's called, I just call it Bevy. And then inside there, I have a folder Bevy, which is my package. So I generally name the package the name of whatever the project is. And like Django has a set, because Django's a really like opinionated framework. It tells you where files need to go. So I might put like the Django project inside its own folder inside of my project folder. It's not necessarily necessary, but oh right, yeah, I forgot I switched to the face cam. Sorry about that. You can see the list of commands. We can switch over. There you go. You can see the list of commands. I just made a package directory, and then I created a init.py, and then I made the dundrmain.py, and then I edited the dundrmain.py to have just like a print statement in it. So I can show that. So like I just edited it to have print hello. So this way, when the package runs, it's going to run this dundrmain.py, and then that's going to. And then when I did the python-m package, that ran the dunder main. Let's see. Was there another? Are path settings required for VMs? No. Because the VM overrides like everything that's going on. Like you saw I did like source, where I did source VM bin activate. That activate file. Let's see if we can't actually see what that activate file looks like. It's just a bunch of commands. And so what it's doing is updating your environment so that it's pointing to all the files it has inside that bin folder. So when you run Python, your terminal itself is looking inside that bin folder first, and then it's pulling in that Python file. So you don't even have to have your path set up. Just so long as that Python file in the bin folder points to a valid Python file, links to a proper Python file, it will run, even if you don't have Python in your terminal's path variable. In that way, it makes things a lot simpler. Any other questions? I don't know what you mean by the same for the bot as well. Did you just mean that I have the bot organized the same way? Yeah. You've probably seen the code on GitHub. Yeah, I organized the bot the same way. Actually, the Dippy bot is organized a little bit differently, in a way. It has a more opinionated structure, and that's just a prototype. And when I actually build Dippy, it'll probably be a little less opinionated. But the current prototype version of Dippy it's using requires you to put all of the files that are going to be run as the bot inside of an extensions folder. So that one I literally have the beginner.codes folder, and then inside that I have all my config files, and then an extensions folder with all of the Python files. So it really depends. If you have an opinionated framework, it can really dictate how your code is going to be structured, how your files are going to be structured. I saw the spammer typing. I don't know if he had a question. Jumping back to a prior question. What is the operation of if while for binary CPU? I mean, if is going to be a jump statement in binary, not necessarily binary CPU. It'd be in machine language. In your assembler, you would write a jump, and that would get interpreted to the opcodes, the machine codes for jump, and doing conditional comparison operations on the CPU. So you're going to end up loading one value and then loading another value, and then you're going to tell the CPU to compare those two values in those two registers, and then put that comparison value in a third register. It's going to get put in a third register, and then you're going to do a jump based on that third register's value. Yep. Any other questions? Avoid is typing. It can depend. You're asking if you should go for a CS major to work as a software engineer. It really depends. Some people need it. I know I was an awkward kid. I needed to go to college. I needed to meet people. I needed to become more socially capable. I was awkward. I was really awkward. That first semester was rough. And I think for me, I went in and I literally was napping in my CS classes. I would show up, take the pop quiz, ace it, go to sleep, come in and get 100 on the tests. I was sleeping through every CS class. I didn't need the degree to get into the industry. I was already quite capable. But socially I needed it. And I do think even then it still improved my skills. I don't necessarily know that it improved my skills to the degree that I paid for it, the cost. But I found it was a valuable experience. I have a lot of good memories from being in college. It was a fun experience. But you definitely could get into the industry without ever going to college. That's one of the great things about computer programming is it's very accessible. It's very easy to get into. And there's a lot of great people just like trying to help other people get into the industry, helping other people learn to code. And because like open source is free, and like all the like books are fairly affordable, there's so much content on YouTube, there's so much free content elsewhere. There's like affordable paid content that's much more affordable than going to college. Like it's so much easier to get into CS than like if you were trying to become like an architectural engineer or a doctor, like you have to go to university, you have to go to college, you have to get an advanced degree. But CS, you just don't. I do think like for some of the more advanced stuff, like I've seen a lot of really competent people like that do crazy stuff, like Will McGugan, who does rich and textual. That is some technically impressive code. That is some incredible code. And he doesn't have a degree in CS as far as I'm aware. I think I read on his Twitter that he doesn't. He just got into the industry. He's been doing it for like 10 years, 12 years. And like he's writing some really good stuff. Like once you start writing code and you start getting that experience, you'll pick it up, you'll understand what's going on. Now some like one thing to consider is if like some people need the hand holding that they can get by going to university. And like getting that structure can really help people. Not everybody's the same. So yeah, it's really going to depend on the person. I would say it's neither here nor there. Like for some people it's great, for some people it's not, for some people it's right in the middle. Like it doesn't matter if they do or they don't. And I would definitely say there's some people who should not. Like they just will not thrive in that kind of environment. It's high pressure. It really is. It's really high pressure. Like my senior year, I was sleeping like 4 hours a night. No lie. Like I wasn't sleeping a lot, and I was struggling to keep up in some classes because I was a project lead for my senior class, and I was putting in a lot of hours to get that code done. That was quite the project. That was a lot of work. Which Python library engine can I use for Android game apps development? Kivy. Python isn't really designed for mobile dev right now. I know the Beware folks, they're really pushing to make Python more accessible to other platforms. They're trying to make it so that it's easier to work with on like Android and iOS and desktop. It's not quite there yet. Kivy's quite advanced. It's quite complicated. You can make it work. You can definitely use Python on mobile. It's just not easy. How important is it to communicate with other people in software teams? Like how good do you have to be at social skills? Communication is key. Like, especially if you're working on a team, you have to be able to communicate with each other quite a lot. Like, you have to be able to communicate effectively. If you can't communicate effectively, you're gonna miscommunicate. And I've had problems with that on teams where there was just a breakdown in communication and we just couldn't get the work done because they would say one thing, I would understand another. I'd come back and a week later they'd be like, this is wrong. Why did you do this? And it just doesn't work. So you have to be able to communicate very well. How social, like your social skills, a lot of software devs are quite awkward. Like, it's not exactly, like, you're not running into a lot of super extroverted people. Like, there's more and more every day. But the majority of your software devs, I think, tend to be more introverted, a little more socially awkward, tend to like to be on their own. I wouldn't worry too much about that. I mean, if you're creepy awkward, like social skills are not there, you're probably going to have difficulty. You're probably going to want to be like have emotional intelligence because it's high stress. Like, it can get really high stress. Like, you might be working long hours. You might have $1 million project on the line. You might have a production just die on you and no one knows why, and you've got to debug it and you're losing thousands of dollars by the minute. That's high stress and you need to be able to handle that If you get into being a team lead, you need to be able to recognize when people are overly stressed. So, like, social skills definitely come into play. You're going to want to be aware of that when you're getting promoted. Like, something I say to a lot of people is, like, I've heard this before. Jobs tend to promote, not all jobs, but a lot of jobs tend to promote until you're in a role that you're not good at. So the more you're aware of your social skills and your emotional intelligence, the better you'll do, and especially when accepting promotions and stuff like that. But yeah, you don't have to be super socially skilled. You don't have to be extroverted. Just as long as you can communicate your ideas clearly, especially like if you can write down your ideas, get them on paper, it's very helpful, and it's crucial. This is an industry where there's really no 10x dev. You can't go in and build really good software all by yourself. Like all the major projects that get really big, it's always a collaborative effort. I don't think I can think of any like major projects that don't have multiple contributors, multiple maintainers. Like, they're out there. They are out there. There are some devs who have put together some really impressive stuff, and it's just them. But it really requires collaboration, and collaboration requires really good communication skills. The ability to sit down and put your ideas down on paper cannot be understated. Do I ever feel imposter syndrome? All the time. Like, you never really know like how good you are, like, and you always wonder if people are just being nice when they tell you that you did a great job. Like, that's always going to be in the back of your mind. I think the people who are really confident and who have no imposter syndrome are the people who just don't know what they don't know. And the more skilled you become, the more knowledgeable you become, the more aware you become of the boundaries of your knowledge. And that's going to lead to even more imposter syndrome. Like, let's be real. The more you're aware of your skill set and what you don't know, the more imposter syndrome you're going to feel. Like, it can be scary, like, sometimes when you get a big project and you're not really sure how you're supposed to do it. Like, it happens all the time. It happens to everybody. And it's just a matter of knowing that you've built the skills to figure out what you're doing. And a lot of the time in software dev, that's going to mean jumping on Stack Overflow, jumping on Google, getting some books to read about the topic. Like, there may be times you get dumped into a project and you've got to have it working. You got to have a working knowledge of the project in a week, and it's using some stack that you don't know. And that is one of the core skills. And being confident in that skill is really how I find I can reassure myself when I do feel imposter syndrome. Just knowing that, like, I've taken on big projects before that I didn't quite comprehend, didn't quite know how I was going to deal with it, and I was able to do it because I've developed the skills over the years to research stuff and look it up and understand what I'm reading. And like, that's another important skill in software development. Just being able to read something and understand what you're looking at. And like, maybe one of these days I'll do a stream on like how to read docs. It can be confusing, and not all docs are the same, and not all docs are of equal quality. Like, I think the Discord.py docs are pretty good. They're a little light on examples. So sometimes it can be, like, especially with this new UI API that they've introduced, I think there's a lot missing there for how to use it. It's not clear how you're supposed to use that API. But the rest of the docs are pretty good. Like, you can jump into those docs and you can pretty much figure out what you need to do just by looking at the docs. But then I like jumped over to the Discord.js docs, and like, I'm able to navigate that, but it takes a little more brain power. Like, those docs are a little bit more confusing. And like, the way they have their like example docs laid out, it's really nice. but I have difficulty jumping between the API docs and the example docs. So like the Discord JS docs, I like them a lot. There's nothing wrong with them, but I just haven't grokked how they work entirely. So, and that can be that's a skill in and of itself, is learning how to read docs, how to analyze what you're looking at with docs, and like just recognizing sometimes you're going to jump into the docs and you're going to have no idea what's going on, even though you think you understand what the docs are doing, because they just aren't great. They just don't explain what you're actually looking at. All right, let's see. I'm glad I made you feel more secure, Void. What exactly was I interested in programming? Other things as well. Well, when I got started, I was 12. Like I got into like model trains, HO scale, 186th, and I had a lot of fun with those. I built a few setups, and I wanted to automate it. I wanted to make it so the trains would start and stop on their own. I never quite succeeded in that. I'm a little bit ADHD in that sense. So I started doing like electronics and like sensors and buttons and LEDs. I even got into digital electronics, and then like 3 years later I got my first laptop, and like one of the first things I did was jump into Windows XP, like the depths of the System32 folder, just like trying to find everything I could. And I discovered some HTML files in there, and I realized I could just open them in Notepad and I could modify them, and I realized I could make my own HTML pages. And then my father did some research. He got me set on BASIC. He helped me install it. So I started writing some basic programs. I got some like simple graphics working, and I had a lot of fun with that. And like I was learning a lot of stuff with that. And then I started playing, since I had my first computer, I got Civilization 3 and started messing with that. And I had a mod builder. It had an exe file hidden in the actual installation folder that you could run, and it was a world builder, and you could edit like how units worked and their stats and stuff. And so like I got into that, and I started messing around with that. And then when Civilization 4 came out, it had Python built in. And like you could literally use Python to mod Civilization 4 and like XML files and all this stuff. So I got my parents to buy me a book on Python, and I learned Python. I think it was Python 2.2. And I started working on that, and I got involved with some communities online, like Civ Fanatics. And that was a great place. It was a great community, a lot of really friendly people. And I started building mods and releasing them on there. I've actually found podcasts that talked about my mods. I was on the front page of Civ Fanatics with people calling out my mods. It was really fun. It was a lot of fun. I didn't really play Civilization 4. I think I finished one game of Civilization 4 in my entire life. My entire day would be spent writing some Python code, modifying some XML files, and then jumping on Civilization 4 with my mod to test it and make sure things were working and see what was broken and what was going to happen and when I ran it. And I had a lot of fun using like INI files to make my mods configurable, and I would release these mod components that people could install in their own mods, that they could put inside their own mods, and all they had to do was edit an INI file, and they didn't have to do anything. It would just load all the Python code for them, and like they just had to edit those INI files to change what units would do what and how the code would impact different things in the game. It was a lot of fun. It was a great starting point. And I think it's important, like when you're starting out, especially if you're not going to college, even in college, it's important to find like a group where you can go and they're like friendly and they're going to encourage you and they're going to be helpful when you have questions. And like I have a bunch of my code from back then. Like I was like 16, 17 when I was writing that code for Civilization 4. And I still have a lot of that code. And it's not bad code. Like I wrote some pretty decent code back then. So yeah. Where were we in chat? Just for other things. So yeah, I got started out with electrical engineering, and that got co-opted by computer programming. Like I literally was looking at the files in Windows, trying to understand how the transistors in the CPU and on that motherboard actually ran programs. And I got distracted by that for the last 16 years. I never got back to the electrical engineering stuff. Have you ever had any problems with your eyes? I'm getting older, so yes. I actually have really good vision for my age. It's not as good as it was when I was 20, that's for sure. I do get eye fatigue. I find it easier to use like a dark mode for that reason. I make sure I try not to have any bright lights, too many bright lights on. I find it easier if it's a little bit darker, but not super dark. I need to have some bias lighting. Definitely need some bias lighting to take the strain off. Are communication skills more valuable than being able to write good code? It can be. If you have better communication skills than code writing skills, you're probably going to end up in a leadership role. But there's definitely a place for that. Or maybe even like in a docs role where you're writing docs for some software. Because like some people just can't write docs. Like I know I have a hard time writing docs. They're getting down into the details and understanding what you need to communicate and how to communicate it in a clear way is very hard. So there are a lot of people who their primary job on a project is to write really clear, really good docs. Even if you don't have the greatest code writing skills, if you can read code and you can understand code and you can understand what's being talked about in a meeting, like where you're discussing how the code should work and what changes need to be made, having communication skills can be very valuable. Having someone on the team who can communicate with other people well and can understand how they think is incredibly valuable. You can take someone who's an incredible coder and you can elevate them by being able to communicate to them. Like if you are a good communicator and you can understand how other people communicate, you can bring that person up and you can help them be a better coder because you can communicate to them in a way that they understand. So yeah, communication skills and code writing skills, both are valuable. And either one as a strength is great. If you have both as a strength, that's even better. That's ideal. But I wouldn't shy away if you're not great at writing code, but you're really good at communicating. Definitely, that's fine. That works. Yes, npm install is very similar to VMs. It's literally like I'm trying to remember. I don't have npm on this computer right now. I don't have Node installed on this computer right now. I just got the computer yesterday. That's why. I normally would. Just haven't gotten around to installing it. But yeah, I think it creates like a Node packages folder that it puts all the packages in, and then when you run Node, it uses that folder. And I think Node is a little bit clearer on all of this because it generally defaults to that. I think if you want to install globally with Node, you have to explicitly do that. And I think that's a better balance than where with Python it installs globally and you have to create a virtual environment. Especially since Python doesn't make it really clear how to create a virtual environment. And I'll tell you right now, off the top of my head, I don't know how to create a virtual environment. The way I typically create virtual environments is either through PyCharm, which does it automatically for me, or by using Poetry to install my packages and dependencies. Maybe another day we can cover like dependency management and like Poetry and pipenv and all that kind of stuff. That's its own rabbit hole. I'm a big fan of Apple. What I think makes your computer so good, they don't run Windows. I do not like Windows. I used Windows XP, like has a special place in my heart because that's what I started with. Windows Vista, I was excited for that. It looked cool. That was on my second computer. The computer I went to college with had Windows Vista on it. It was definitely buggy. It was definitely slow, but it was a really cool operating system. It had like the glass look to all the windows and stuff. It looked so much cooler than Windows XP. And Windows 7 was a really solid OS. And like Windows 10 is a really solid OS. And I'm sure Windows 11 will be a solid OS. I just find that the way Microsoft organizes the operating system and handles everything is a bit of a hassle, and they're definitely making it better. They're definitely making it better. I definitely prefer having a Unix-like operating system, though, where I can use very similar commands to when I jump onto a server. Like, I'm working with servers all the time, less and less in the age of DevOps, but knowing how Linux works and having an operating system that works very similarly helps me write code that works on either one without having to think about it. And that's very valuable to me, especially since I do a lot of back-end stuff. And that's where I prefer to be, is on the back end. And a lot of my, like, Linux runs on most websites. Like, almost everything runs on Linux. If you're using Docker, that's going to be Linux 99.9% of the time. Like, it's only until recently you couldn't even use Windows on Docker. Yeah. So, yeah, that's why I prefer Apple. Like, I like the hardware. I'm not a big fan of, like, building my own PCs. Like, that, I don't like to deal with, like, installing drivers and having to deal with stuff when it breaks down. I like the convenience of just getting a computer that works most of the time, or all, like, I've not had any issues with my Macs. I've been using them for 8 years. And I've had no issues. I've never had to take a Mac to the Apple Store, nothing like that. I still have my 2014 Mac Mini. It's still running great. I think my brother still has my 2013 MacBook Air. The only computer I had issues with was my 2015 MacBook Pro, but that was the keyboard, and those butterfly keyboards were notorious for problems, and the guy had those problems, and that's part of the reason why I got the 2020 MacBook Pro, because it got rid of that butterfly keyboard, and that's a really good computer. I've got it right here. They did have problems running warm, and that's more on Intel, because Intel didn't make great chips. Like, their chips have been struggling for a few years, and that showed up in the Macs. And I know, like, I see people with their i9 MacBook Pros, and it's like, why did you get that? It doesn't have the thermal envelope. Like, it's not getting all the performance it should be. You're probably better off getting an i7. Yeah, I just have never really gotten into building PCs, so Windows doesn't really... I don't need to have Windows. I don't have to put Linux on a system to have Unix. I can just stick with Mac OS. I don't have to deal with any fiddly OS to get my Unix environment. What is there? Looking at these questions. On average, I don't know off the top of my head in the U.S. what we earn as programmers. It's a decent amount. It's gonna vary. It's gonna be like in the high tens of thousands, up into the hundreds of thousands. Like your FANG companies, your total compensation with stock options and all that stuff is gonna be $300,000-$500,000 within a few years. A lot of companies are gonna start you at a lower rate. Like in FANG, it's going to be 100,000, 200,000. Like, it's going to be six figures in FANG. Yeah. What makes you a good programmer? Being able to think through a problem, being able to break it down into individual steps, being able to understand what you're reading. Like, you need to be able to look at docs, or you need to be able to look at a requirements document, and understand what you're looking at, and understand what it's saying. So reading comprehension is really important. Being able to sit down in a conversation with a client, with your boss, with whoever the stakeholder is, and actually talk about the project. It's very important to be able to understand what they're saying. So communication, being able to understand what you're reading and being told, being able to break a problem down, whether it be breaking down a problem into the individual steps that you're going to write lines of code to complete, or if it's going to be looking at a bigger project, like how am I going to break it down into, like, am I going to need an API gateway? Am I going to need a load balancer? Am I going to have to use Docker? Am I going to need Kubernetes? Like, be able to break down the entire project That is an important skill. Like, just being able to break down things into their individual components and understanding how to make that work. So what makes it? So yeah, just being able to break things down, being able to understand what you're seeing and reading, what you're hearing. I have not used Windows 11. I imagine, like, I feel like right now it's in its early days. I can't imagine Microsoft isn't going to make it stable and solid at some point. It's early days for Windows 11. The questions asked in the thread, possibly going to do, I mean, this isn't going to be the only live stream. Like, we're definitely going to probably be doing this again in the future. I'm having fun with this Q&A right now. We can definitely think about what we're going to talk about. Some of those questions might actually be better suited to videos. I might live stream some. I might need to do some blog posts. I know some of them will require me to do some prep. And I just didn't have time to do prep. Like, this is literally, I got OBS all set up a little after 6, and I wanted to start at 6. So, we're flying a little bit by the seat of our pants. And being able to just pop open a virtual environment and walk through the files and stuff was easy enough. So, that's why I went with that one today. Let's see. Got some long ones. Yeah, I think we'll start wrapping it up here. I think it's been almost an hour. It's been about an hour. Let's see. Void asked the question. Let's see if it might be something quick. Do I think having one language that does everything, or having many languages that are good at specific things? I think the languages we have right now aren't the languages we're going to be using in 100 years. There are things that most languages right now either do poorly or don't do it all, or they do it and they're not a great language. I think a language needs to be approachable to anyone, and I think that, like, some of the languages experimenting with, like, being able to formulate, like, almost a proof that demonstrates that the code will do what you expect it to do, and give you guarantees that the code isn't going to break. A lot of those languages are not approachable right now. And someone's going to figure out how to make that happen. And I don't know when it's going to be. I've got some ideas for a language that will incorporate things I have not really seen in a language proper. Things I've seen, like, that we're moving in that direction, but it hasn't been incorporated into a language proper. I don't know that we'll ever have one language that rules them all. And mainly the reason for that is I think there's not a need. There is value in not requiring a language to be typed. Like, having dynamic typing, having loose typing is very valuable. Like, it makes a language much more approachable, allows you to build projects much more rapidly. There's a lot of value in that. It brings a lot of simplicity to the language. It's like, if you look at C++ and Python, they're very similar in what their abstract concepts are. Like, they have classes, like a lot of that stuff that really adds abstraction, allows you to abstract away the logic on your project. But one is a lot harder to learn than the other. Like, you can pick up Python in an afternoon, and you could spend your whole life learning C++. But the value of C++ is that all that complexity brings performance, because you can write code that's more closely aligned with what the CPU expects. So you can really optimize. You have a lot more control over how memory is used. Like in Python, you have almost no control over how memory is used. You're having to deal with the garbage collector, which slows your program down, because that's literally a part of your program that you didn't write that is running in the background. And it's going through and checking all this stuff. And like that slows stuff down. So any language with garbage collector is going to be a little bit slower. Or a lot slower in some cases. So there is value in having that typed system with like where you're managing the memory yourself. And then there's value in a system that doesn't require you to know all that, doesn't require you to do all that. And like there's a lot of pitfalls. Like Rust is trying to address this stuff with like the memory management. And like that's important going forward, because like in the past you would want to use a language like Python or JavaScript to build websites just strictly because if someone did something weird, sent a strange request to your web server, you didn't want it to explode. You didn't want to write C code that would buffer overflow because someone sent a strangely formatted string in their request. And like Python and JavaScript handle that for you. You don't have to worry about the memory structure at all. And so there's value in both systems. So there's value in having multiple languages. And I'm not sure we'll be able to get like I really think we do need like languages that provide guarantees on performance. And like making sure your code is going to work. Like banks need that. The stock market, like anything working with the stock exchanges, needs to know that code is going to run. And you don't get that with Python. You don't get that with JavaScript. And like, but you do get that with some other languages. And I hope someday that those languages become simpler and easier to understand. But there's always going to be that value. And I don't think they're always going to be the simplest languages to understand, because that's really mathematical stuff going on there. So yeah, I don't necessarily think we're ever going to get to just one language. We might get to a consensus on what syntax should look like. Like you have a lot of languages that look like C, that aren't C, that work in very different ways. And I think that's probably going to be how things are going to go forward. Like we're going to see a lot of very similarly structured code in languages. But yeah, I don't know that we're ever going to get down to just one language, and I don't see there's not really any value in necessarily doing that. Picking up a new language is fairly easy once you learn how to code. So there's not a lot of value in just bringing it down to one language. You don't get a lot from doing that, and having different languages makes things a little bit easier, because you don't have to necessarily know everything. You don't have to know the pitfalls that come from like having a typed system that's mixed with like a dynamic system. Like, so I think going forward, we're probably going to see multiple languages, and like people have different preferences on style. Like some people do not like the way Python code looks, and like I know I don't care for curly braces. So just on an aesthetic level, you may see multiple languages going forward. All right, let's see. And as far as like Java is a good point, being bloated. I think any language that tries to do everything is going to be bloated. It's going to be slow. At the same time, Java is great because you can build just about anything in it, and you're going to get a decent level of performance. And I think Go is actually going in the same direction as Java, but without the bloat. So I think if you're interested in that kind of stuff, Go might be interesting. If like you're interested in having a language that's just like good at like a lot of stuff and it's performant, Go is an interesting direction to look. Let's see. What study you need to build a compiler? You're probably going to want to go to school for that. Like, you could definitely learn it outside of school. But it's more complicated stuff. And that's going to be a computer science thing. you're going to want to study computer science. Like, you might even want to get a master's degree in CS. Compilers are a complicated beast. They do a lot of stuff. They are very complicated. And you're probably going to want to you're going to need to understand how, like, the operating system works. You're going to have to understand, you're going to want it to work on multiple operating systems. Nobody wants a programming language that only works on Windows. Nobody wants a programming language that only works on Linux. So you're going to have to know how to write a compiler that works across the spectrum. So you're going to need to hook into tooling that already exists, because you don't want to reinvent that wheel. Like, that's a really complicated thing to make a cross-platform language. So you're going to, at some level, need to tap into the tooling that already exists. And, like, that's where, like, your linkers come in, LLVM comes in. But compilers are a complicated subject. Interpreters are a complicated subject. Interpreters are an easier starting place, though, because you're writing it in another language, and you don't have to think about how the computer works. You just have to think about how that language works. So you're essentially building an interpretation layer, which is why it's an interpreter. An interpretation layer that takes your code syntax and converts that essentially to functions that run the same code, but in the syntax of the language your interpreters are in. So interpreters are definitely easier to get started with. You can do them a lot easier. What do you need to say? Programming language? Similar. What do you need to study to build a programming language? It's going to be like parsers. You're going to need to learn about, like, how the operating system interacts with the, like, binary files. If you're building an interpreted language, you just got to basically learn another programming language, and you're going to write a program that runs code written in your programming language that you created. So if you want to dabble with writing programming languages, mess around with interpreters. You can find a lot of parsers. Like, this parser is written for Python. So you could take Python and you could build your own interpreted language. Write in Python fairly easily. Like, if you want to look at the beginner.code's bot, on the main branch, there is the brainfuck interpreter that I wrote. It's pretty simple. It works for most. There's a little bug in there somewhere that causes some BF code to just not run. I'm not sure what it is. I've not had the time to debug it. I've not had the time to figure it out. But yeah, it's not hard to write an interpreter, especially once you understand, like, how stacks work, like how, like, Python uses frames on a stack to, like, keep track of state on your scope and your variables. So you just got to figure out how to track all of that stuff. Before I went to college, I wrote a simple config language that was very INI based. Like, it looked like INI, but it had some of the complexity and the extent, the deeper structurability of XML. So, like, you had closing tags and you could have nested tags. So, like, you had parent and child elements. And I wrote that before I even went to college. And that had scoping and variables and all kinds of fun stuff like that. Another one I wrote a simple HTML template language that used HTML as the control structure. So, like, any conditionals, that was an HTML tag. And then you would run it through my template engine, and it would interpret all that. And there was a whole stack, and there were variables on that stack. So you had variable scopes, and you could set variables and all that fun stuff. And it wasn't even a programming language per se. On some level it was, because you could create variables. You could do if statements. You could do for loops. But it was all HTML tags. It was very interesting. And that's one way I mess around with that kind of stuff. Does the software industry need brand new programming languages created every few years, decades? No, it doesn't. If you like one that I've heard, I think it was Uncle Bob did a talk where he talked about how in the past, like accounting, didn't have the dual ledger. And like they were using different ledger systems, and over time they arrived at the dual ledger. And that's what they use to this day. And that is the industry standard. And all that churn that they had early on in the accounting industry has consolidated. And we will likely see that in computer science at some point. And we won't have new languages all the time. Right now, we're going from an era where all of our computer programming languages were oriented toward very limited resources. Like everybody was trying to squeeze out every last CPU cycle, every last byte of memory. And that's just not as necessary anymore. Like even Rust, which is a systems language, does a lot more in its binaries. Like a Hello World Rust binary does a lot more stuff behind the scenes than a C binary for Hello World. So we're seeing an evolution from optimizing for limited resources towards optimizing for languages that are more dependable and reliable, and that you can just expect it to help you write code that isn't going to explode. You're not going to get, like, ideally, your Rust program will never have a Stack Overflow issue. You're never going to go beyond the bounds of an array in Rust, unless you put it in unsafe mode. Like, that doesn't happen in Python. That doesn't happen in JavaScript. Like, there's, like, so many of the more modern languages, and this has been happening, like, over the last 30 years, we've been slowly moving towards this. I haven't messed with Go too much, but I don't think you have these, like, the same kinds of, like, memory issues that you have in C, C++. And going forward, we're going to see more and more like that. Yeah. I think I'm going to give it a, like, if we got to, like, I see Moses is telling me to hold his question. He's got a nice big one there. We can pin that or save it somewhere. And I do think we're going to wrap up. If there are any other quick questions, and just to recap on that one question Bobby asked, I don't think we need new language every few years. It's going to consolidate. And I can see there are some holes in what the languages offer right now. And I think eventually those holes are going to get plugged, and we're going to arrive at a feature set and an expectation of programming languages. And there may be a day in the future, 2300 maybe, where we have a few languages that are like the languages that people use and that will be used going forward. Something I find interesting, though, is that I don't know of a single language that isn't oriented towards English speakers. Like, I have not seen, like, a Chinese language programming language. I haven't seen anything like that. And I don't think English is necessarily the only language suited to computer programming languages. And so it'll be interesting to see in the future if we have some major languages come up that are in other human languages. So, yeah, that's an interesting question. All right, Moses is back and wants me to address his question. So let's go back to it. Let's see what it was. Lower level side of programming. How can I dive into the lower level side of programming and systems, like with C++ and C? You understand the syntax, how it works. Writing hex codes in C++. I'm not sure necessarily what you're referring to with hex codes. Like, hex codes can mean a lot of things. They might be... I doubt they're writing machine code. The reason why is because if you're writing machine code, that's going to be limited to the language of the processor that you're targeting. So like when we talk about x86, that's a language on that processor. Now, even different generations of x86 processors are going to have their own instructions. Might have their own instructions. So you may target an instruction that isn't available on another computer. And what'll happen is, if your program tries to run an instruction on a CPU that doesn't support it, is your program will crash. The computer just will not know what to do with that current step in the machine code that has been generated, and it will just explode. So if anybody's writing hex code, it's going to be very targeted. Like, it's going to be just like a Windows only thing, or like something designed just for like a specific set of Intel processors or AMD processors. But you might also use hex codes. Like, I see hex codes in like bot code written in Python for colors. Hex codes are just numbers. So I don't think, it's hard to say exactly. Like, I wouldn't say you need to know how to write code using hex codes. And I would question if anybody even is. They may be writing assembler or even C code, and then compiling that and placing the hex representation of those bits into their code. So I wouldn't worry too much about learning about like all that stuff. Like using like different logical using different logical operators, they're just setting flags. So what that means is you have a binary string. You have like a list. You have a binary number of ones and zeros, and you have a bunch of settings that are just true or false settings. So what they're doing is, and like this isn't really necessary nowadays. It was more necessary back in the days when you had limited resources, and you just wanted to store a bunch of settings. You would store them as a bunch of ones and zeros in a single byte or a set of bytes. So each bit in that byte was a true-false value, and we called that a flag. And so they're just using bitwise operators to extract the setting for a specific flag. So like you're going to end up using the shift operator to get to the correct bit, and then you're going to use an AND operator to mask out all the bits you don't care about. We can actually, let's see, maybe we can pop up Python real quick. Let's just have x equals 8. And if we do bin x, you see that we have the fourth bit is set to 1. All right. We can shift that. We can do, let's do bin x shift 3. And now we've shifted it so the 1 is all, like Python doesn't show you a byte. It's just showing you the most basic, simplest, rounded down version of that binary representation. So it got rid of all the leading zeros. It just shifted it over. So and then if we did x equals 9 and we did bin 9, we're going to see we have 2 ones. Well, if I hit the right letter there. If we do bin x, now we have 1001. So if we wanted to just see if that first flag, that fourth digit there, that last one, is set. If we want to know if that was set, what we would have to do is we would do x and then we have to get rid of those leading digits because we don't want to look at them. We don't want to see them. So we've got 3 digits that we need to eliminate. So what we're going to do is we need to get this binary representation, and that's going to be our mask. And the way we do that, in Python, I'm trying to think if in Python, all you have to do, because all that number is 1, right? So what we're going to do is we're going to do x, let's do bin x and 1, right? And we get back 1, okay? That's just grabbing the first entry. But let's say we have x equals, Let's do, I'm trying to think. Let's do 15, because that is all once. Let's say we want to figure out what the third, this one right here is. In order to do that, we need to do bin x shift 2, because we got to get that third one over. And then we got to do and we got to get this binary number. Or actually, no, we're just going to do 1 and 1. And that'll, because like if you look at, like if we do x2, we still have 11. So we got to get rid of that other 1. So we can do and 1, and that gets rid of that other 1. So that's all that's happening, and they're using those bitwise operators, is they're isolating an individual bit in a byte, so that they can get the value of that flag. Yeah. I'm reading a book called The Programming Primer. 1970s. Wow. Basic Pascal C. Yeah, a book from the 1970s is going to spend a lot more time on low resource code that's optimizing to get every ounce of performance out of the limited processing resources that those computers had in the 70s. So those books are going to get a lot deeper on like actually manipulating bits. And there's a lot of interesting stuff there. It's not necessarily necessary anymore, though. Like, I don't think anybody's going to complain if you output their data in a JSON file where your flags are literally equals true versus equals 17, where the 8th bit is the value of that flag. So, just nowadays, our computers can handle so much more. They're so much faster. So, yeah. Any other real quick questions? It's 7:30 for me right now. We started a little after 6. So, it's been about an hour and a half. This has been it's been a good stream. A good inaugural stream. It's been pretty good. I think we've kept up a pretty good pace. Once we got those questions flowing, it really started going. Why is OOP so important, and what is it exactly? OOP is important because it adds abstraction. You can create code that isn't necessarily fixed to a specific set structure. Like, you can have very abstract concepts. Like, you might have an extension concept, and you don't have to have a function that specifically understands all this stuff. It can just understand that I'm getting an extension, and that this extension does certain things. You could think of it like the classic example of the animal class. You can give a function an animal class, and that function will automatically know that that animal can walk, or it can make a sound. And it doesn't have to know that it's getting a dog or a cat. It just knows it's getting an animal. So it can call the walk function, or it can call the speak function. And so that abstraction, it's often called interfaces. That abstraction adds a lot of value to developing code that is easy to understand and easy to conceptualize in your mind, because you don't have to know every function that you're going to have to use. You just have to know how an animal object works. You don't have to know what types of animals, or what type of animals are going to be passed to your function. You just have to know that you're getting an animal. So you don't have to know if you're getting a dog. You don't have to know if you're getting a dolphin. You don't have to know if you're getting an elephant. You just care that you're getting an animal, and you're going to do your thing with the animal. And that's where OOP is important. And so it's just a way, what it is just a way to organize ideas and to organize data. And like, each object is just pairing data with behavior. So you have your functions, which are your behavior. They're your verbs in a sentence. And then you have your data, which are the nouns in your sentence. So like, you have your animal name, which is a noun. It's like you're gonna, and then you have your animal behavior like bark or speak, eat. Like these are your behaviors which are going to go on that object. And being able to break it down to those abstract concepts is really useful. You don't have to have a function, dog bark or dog eat, and then another function, cat eat. You have an object, animal, that has functions, eat, bark, and then you create classes that implement those functions, and get the data that needs to go into there, and then it makes it a lot easier to understand what your code is doing, and you have to think a lot less about what's going on in other files of your project. It's a great thing to understand, and I understand why people find that it can be confusing. It can be cumbersome because if you're not careful, you'll have an explosion of objects that do all kinds of crazy things. You're 5 levels deep in your inheritance and you don't even know what functions are available to you. You don't know what functions have been overridden. And it can get messy. It can get messy real fast. And functional programming can be a lot easier to understand more procedural things, like things that go in steps. And so like there's value in functional programming too. I don't think one way is better than the other. I don't think one way is necessarily the way to go. I think there are applications where one way makes more sense than the other. And it's a matter of learning the balance. And like I've studied functional programming and taken the principles of functional programming, and they can be combined with object-oriented programming. You can do a lot of functional stuff on your objects, and that combination can really be powerful. So in understanding how functional programming works, how object-oriented programming works, both are very valuable to know, even if you prefer one over the other. All right. I think we've hit all the questions. I think that's pretty good for today. I think we're like exactly at an hour and a half at this point. It's been a lot of talking. I need to go get something to drink. I need to go get some dinner, and I need to do the weekday challenge. How many people did the weekday challenge this week? Did we get enough submissions to make that worthwhile? We've got one submission. I'll give you guys another day. Another day to figure that out. Figure out how to do that challenge. It's not a hard one. So, yep. All right. Well, I think that concludes our inaugural Zech Talks code. Have a great night, and we'll have to set this up again and do it again. Maybe next month. I've got a bunch of time off this coming month, so we'll definitely do something this coming month. I've got some ideas. We'll figure out what we're doing. I want to make some videos. I'll put this up on my YouTube. I think the recording should have worked, so I'll put this up on my YouTube. It's all right. Y'all have a good night.